Remember, guys, in the spirit of 2023, we are not erasing anything on our notes. So change colors right now. Whatever you got wrong, just write it down in a different color. Who feels confident about their answer to number 11? Matthew, go for it. Excellent. How did you get that?
The two minuses make a plus.
Good.
And then you add it, and then you get 72.
44 plus 28 should have given you 72. Guys, I saw some people multiplying these. Make sure you understand this is a subtraction symbol, okay? You can multiply the two negatives by each other, but you do not multiply the 44 and the 28. Okay, number 12. The answer to a multiplication problem is the blank. Miss Alonzo.
The product.
The product is correct. I saw a few people, it's okay that you did, but you put sum here. What is a sum? Addition. What's a difference? Subtraction. Which one do we use for addition or division? What do we call it? A quotient. Okay? All right, number 13. Did anyone get number 13? Karen?
So basically, I moved the so it's like it's 3.4 divided by 0.5. So
Okay.
I moved the 5 and the decimals and then both of them.
Okay.
And I got 5 divided by 35, which is 7. So I just got 7.
Whoa. You changed that 4 to a 5 though. Remember, it should be 5 going into 34. But I agree with you on moving the decimals. That was a very smart move, Karen. Natalie, can you finish this one?
Yeah, so first, 5 can go into 3, so put a 0 there. And then you bring down 34 as it is. So 5 can go into 34 6 times.
Okay.
Which is 30. So then you bring down the 4 because that's your difference.
Okay.
Whatever. Then you make a 0 next to the 34 because it's already there.
Uh-huh.
And then 40 and 5 can go into 48 times. So the answer is 0.68.
Remember, your decimal was next to the 34. You bring it up. It's 6.8. Very good. I saw a lot of people get this one right. I was very happy about that. Matthew, what's up? You want to do the next one? Okay. Number 14. I'm going to ask your partner to do the next one. McCarvin, did you guys agree on this answer?
Yeah.
What'd you guys get?
Yeah, 4 divided by x minus 6.
Good. You can write it like this as 4 divided by x minus 6. Remember, whenever it says a number, you should have used a variable. Did you have to use x? No. What else could you have used? N. What else? Y, A, any letter. Okay? Now, I would recommend that we write this a little bit different. Did anyone write it a little bit different, Karen?
Yeah, I put 4, the division bar, x minus 6.
Good. 4 over x minus 6. Guys, these are both correct. They're both saying the same thing, but primarily, especially on the SAT, you're going to see this second one a lot more. Okay? All right. And then for the last one, Salucci.
34,716.
Very good. 34,716 was the answer. Okay? Guys, I need you to be honest here, and I need you to just write a score in the top left corner. If you got 4, put 4 out of 5. If you got 3, put 3 out of 5. If you got none, put 0 out of 5. Be honest there, okay? This is not going to be graded. I just need to know how well you did on this warm-up, okay? Today we're talking about systems of linear inequalities. Okay, remember what systems of equations were? They just meant that there was more than two or more equations, right? So when we're talking about inequalities, it just means 2 or more linear inequalities, okay? Now, they have to have the same variables, and 99 times out of 100, those variables will be X and Y, okay? So your solutions, you guys remember for solutions of systems of equations, it was 2 variables, it was an ordered pair. It had a value for X and it had a value for Y, right? Now, if you're going to pick a point and it's going to be a solution to a system of inequalities, it has to be a solution to each. Circle the word each. Has to be a solution to each of the inequalities. That means it cannot satisfy one and not the other. It's all or nothing, okay? Has to work for both. Otherwise, it's not a solution. Okay, let's just do a quick little refresher. So take a glance over here on the left side of your page. It says, are these true or false inequalities? Is the first one, is 4 less than or equal to 4? Put a T, okay? That is true. Why is that true?
Because 4 is equal
It's equal to 4, right? But is the bottom one true? No, this one's false. Keep very, very close attention. Pay close attention to these examples popping up in today's lesson, okay? Because some of them will tell you it works for the inequality. Other ones will tell you it doesn't work, okay? And you have to be very careful about that, all right? Okay, so let's take a look at example 1. We're telling whether each of these ordered pairs is a solution of the inequality, linear inequalities, okay? Now, you do not have to solve this system of linear inequalities. It's asking whether this is one of the solutions. How do we test whether something's a solution? You plug it in. So we're going to replace 3 with what variable? No? X. And we're going to replace 5 with what variable? Y. Okay? So go back into your inequality, grab the y, and put what instead of y? 5. So it's going to be 5 is less than 2 times 3. What's 2 times 3?
6.
Is 5 smaller than 6? So we're good so far. Is it a solution? You don't know. Why don't we know yet? You have to check the second one, okay? So grab the second equation, parentheses around y, parentheses around x, and substitute in. You're going to get 5 is greater than or equal to 3 plus 1. Is 5 greater than or equal to 4?
Yeah.
Yeah. So if it works for both, what can I say about this point? It is a solution. Pretty good so far? Okay. Any questions on A? Let's go to B. What do I do? Plug what in? 0 for y, negative 2 for x. Okay, let's do it for the first one. What do we get? 0 is less than negative 4 because we're taking 2 and multiplying it by negative 2. This is not true. Can I stop? Yes, because it has to work for both. Do you guys agree? So as soon as it doesn't work for one of them, you can stop. If you continued, it would work for the second one, but we do not care, okay? We can stop. We can say this is not a solution. I'm going to put SOL for solution for abbreviation. Are there any questions on B? Okay, I want you guys to try C and D on your own. We'll go over them in 1 minute. Take 30 seconds. You should have gotten no for the first one, yes for the second one. Make sure your group's on the same page. Go. Yes, you may. Okay, peeps. The first one, when you plugged it in, you would have gotten 5 is less than 5. True or false? False. So the answer is no, okay? It was not a solution. The second one, it would work for both. You should have gotten 4 is greater than or equal to 4, which works because it's 3 times 1, which is 3, plus 1, which is 4. And then you would have gotten 4 is greater than 0 because 1 minus 1 is 0. And this one works as well. So it should have been yes. How many of us got both of those right? Let's go. Okay, moving on. All right, now we're going to start graphing them, okay? Now, we've dealt with graphing one of these guys by themselves. But what happens when we graph 2 of them, okay? When you graph 2 of them, there's going to be a region where the shaded parts overlap. That is the region where those points will work for one or both? Both. So circle this region over here. This is the region where it's a solution, is a solution. to both inequalities. Okay? So for example, -1, 0. Do you see how it's in the region where the red and the blue shaded regions touch? Is that a yes or a no?
Yes, yes.
You guys see that?
Yes.
So that point would work for both inequalities, right? Take a look at 3, 0. Is 3, 0 going to work for both of the inequalities? No. Will it work for one of the inequalities? Yes, it will work for the inequality that's in blue because it's in the blue shaded region. What about if it was 0, 4? Will it work for both? Will it work for one? Yes. Okay. It won't work for both, but it will work for the red inequality. What's up?
What if it's on the dotted line?
What if it's on the dotted line? If it is on the dotted line, it does not work for the dotted lines inequality. Okay? Because remember, those dotted lines represent like that's your boundary line, but if you're on the line, it's not going to work. It's not going to satisfy that inequality. Because you're going to get something like 4 is less than 4, right, Matthew? And this you would say does not work, right? You can have any number that's slightly less than 4, but you cannot have 4 there. Yes?
What about if it was a normal line? Like the
If it was a solid line like the red one, points on the red line are solutions to the red line. Okay? Good questions. And lastly, guys, if I put a point up here, is this point a solution to both of the inequalities? Yeah. It is?
No.
No. Is it a solution to one of the inequalities?
No.
No, it's going to fail for both. Okay? So this is what our shaded regions represent. It's either a solution to both, one, or none. Okay. Now, to graph these, we do the exact same procedure that we've been doing. We follow our 3 steps, so we have to do it twice now, and we're going to get overlapping regions. So let's check it out. Let's do letter A. Let's start with y is less than or equal to 3. Brayden, what was my first step for these kinds of problems? Good, put an equal sign. So it's going to be y equals 3. Brayden, how do you graph that?
Put 3 on y.
Mm-hmm.
And go up one into the right one.
Okay, it has a slope of 1. I disagree.
It's a vertical line.
It's not a vertical line, it's a horizontal line. Remember, how can we remember that? You take a y, and if you flipped a y upside down, wouldn't it be like a squiggly h for horizontal? Remember, y equals is going to be horizontal, so it's a horizontal line through 3, solid or dotted.
How do you know whether it's solid or dotted?
How do you know whether it's solid or dotted? It's this symbol up here. If it has the equal sign underneath, is it solid?
Yes.
Yes. If it doesn't, what is it? Dotted or dashed, okay? All right, so this one has to be solid. Second step. Colin, what was step number 2? AJ? Pick a point. What point do you want to use, AJ? I would love to use 0, 0. You're speaking my language, okay? So pick 0, 0, plug it in to the inequality, not the equation. Are we clear on that? Which one is the inequality? This one
No,
or this one?
that one.
The first one, okay? An inequality has an inequality symbol, not an equal sign, okay? They will all fail the equation. So you have to plug it into the inequality. So step number 3, replace y with 0. Is 0 less than or equal to 3?
No.
Sure about that?
Sorry. Yes.
I would say 0 is smaller than 3. So if it works, Salucci, what side of the line do I shade? The bottom. You want that point as part of your answer. So we're going to shade the bottom. We should all be fairly comfortable with this part of the graphing, right? Now we're going to do the exact same thing, but we're going to keep this one on our graph. So we're going to graph on top of it. Change the color that you're using. I'm going to use red, and we're going to do the same thing for this inequality. Y is greater than x plus 2. What do I do as step number 1, guys?
That's the line.
Equal sign. So it's going to be y equals x plus 2. Andrea, can you graph that for me? On what axis?
On the y-axis,
Okay.
and then you go up one to the right.
Perfect. Solid or dotted line, Andrea? Good. Doesn't have to be perfect, guys. Dotted line with a slope of 1 and starting at 2 on the y-axis. Okay, what was step number 2? Segi,
Pick a point.
pick a point. What point do you want to use?
1,
1, 1. Perfect. Pick 1, 1. That's right there. You plug it into the inequality. You're going to get 1 is greater than 1 plus 2. Is 1 bigger than 3? No. If it fails, Juliana, which side of my line do I then shade?
The top.
The top. Very good. So if you shade the top, you'll start to notice, where is my double shaded region? Matthew?
So on the left side, where we're both on top of each other.
Very good. On that left side where both the blue and the red meet. Guys, I want you to take a different color and really shade that in so it's very obvious that that's your answer, okay? All right, now you're probably wondering, like, how do we do this on an exam, okay? So when you're shading the red and the blue, right, I would like you to shade them very, very lightly, right? That way you just need to tell, okay, where is it supposed to be shaded for both? And then you go over that region and just darken it in a little bit, okay? One region should be significantly darker than the rest of it, so you're showing me that it's the solution. If on the test you're like, I really can't tell if Ms. Jurko is going to see this, guess what? You can just draw an arrow and be like, this is the solution. Okay? But most of you are going to be pretty proficient at it. You're just going to shade really lightly and then shade in dark this portion where they overlap. Okay? Go ahead, McCarbon. All right. On big ideas, one more thing, guys. On big ideas, just FYI, they erase where it's not shared. You don't have to do that. I'm just showing you, like, if it's a multiple choice question, they're going to have both of those parts erased, and the only part you're going to see shaded was the combined solution set, okay, where they overlapped. All right? What's that?
Will the line still be there on big ideas?
The lines will still be there on big ideas, okay? All right, let's keep going. We're going to do one more example, and then we're donezo, okay? All right, take a look at C. In C, we've got negative 2x plus y is less than 4, and 2x plus y is greater than 4. Alfonso, take the first inequality. What do I do with it?
You turn into an equal sign.
Good, turn it into an equal sign. Negative 2x plus y is equal to 4. Alfonso, what would you do after that?
You pick a point.
Not yet. Gabriel, help him out.
You put it on 4.
Eventually we do put it on 4,
You have to add.
but we have to do something first to this equation.
You add the x.
Good. Why do I need to add 2x to both sides?
You have to move the y equals x plus b.
Excellent. We need it in slope-intercept form. Good. So I'm going to get y equals what, Gabriel?
Y equals 2x plus 4.
Excellent. Now I can start on the 4, Gabe, right?
Yeah.
And I can do what from there?
You go
Up how many?
up 1, right 1.
No. What was my slope here?
2.
It's 2, right? So my slope is 2. What is 2 as a fraction? 2 over
1.
1.
So up 2, right 1.
There you go. Up 2 to the right 1. Perfect. Ayana, is this going to be a solid or a dotted line?
Dotted.
Dotted. Very good. Okay. So it's going to be dotted. Do your best. Doesn't have to be perfect, guys. And then once it's dotted, I now need to pick a point, Alfonso. Okay? So, Alfonso, I want you to pick my point for me in step number 2.
0, 0.
0, 0. I love it. 0, 0 is down here in the middle of my graph. Mia, plug it in. What do I get?
You plug it into the inequality.
The very first one. Very good. Mm-hmm.
So it would be -2 times 0 plus 0 is less than 4.
Okay.
2 is less than 4.
0 is
I mean,
less than
0 is
4.
less than 4.
Is 0 smaller than 4, Mia?
No. I mean, yeah.
Yeah, it is, right? So I would put a check mark. I want to shade now that point. I want that point to be shaded. Seb, what does that mean? Where do I shade now?
To the right.
To the right of this line, okay? So go ahead and shade in whatever color you did this problem in to the right of that line. Caden, can you walk me through the second one, please?
We started at 4, goes down to
Oh, hold on. You skipped a few steps there. You are correct, but walk me through the steps. Okay, so 2x plus y equals 4. Okay. Okay, how do you graph that? Okay. Okay. Dotted or solid? Good. Okay. All right, what point do you want to pick? I love it. 0, 0. Where do you plug it in? Good, for the very beginning, right? Oops, this is step number 3. So 2x plus y is greater than 4. You get 2 times 0 plus 0 is greater than 4. What do I get here? 0 is greater than 4. True or false? False. What does that mean? You put the highlight on the other side. So I don't want this point highlighted. So I highlight to the right of the blue line. Do you guys see that? Mia, what's up?
I don't get how you got your. Oh wait, you did the blue in the second one?
Yes.
Okay.
Emma, can you tell where these regions overlap?
They overlap on the right.
Very good. In that right corner, okay? So you're going to take a black pen or whatever is going to stick out to you and just shade in darkly that region over there. Okay? Andrea?
Why couldn't it be in that like little corner there that I don't know how to triangle?
Oh, the triangle up on top?
Yeah.
Because didn't we say we had to shade to the right of the red line?
Oh.
This region in this blue triangle is to the left of the red line. Do you see that?
Yeah.
Okay. Good question. Are there any other questions?
Wait, how do you know like which one is shaded, like which side is shaded with 0?
Because we tested this point, right? 0, 0 for the red one, right? It worked. It gave us 0 is less than 4. So we knew, okay, the red shaded region should include 0, 0. But the blue region said, no, it doesn't work. So don't include this point. Do you see how the red dot, 0, 0, is only shaded by the red?
Oh.
The blue shaded away from it. Does that make sense? Okay.
I have a question.
Yeah, go ahead, David.
For like the solution that works for both of them, how do you know where to shade for that?
Where it works for both? Well, you have to be able to tell where your regions overlap, right? So do you see how in this black region, if I take out the black markings that I drew? Let me try to, yeah. Do you see how only black and red overlap in that area over here?
Oh, okay, I got it.
Otherwise, it's only blue or it's only red. So we know now that this becomes our region of double, like where they both work, okay? And if you need to, you can just point this out. This is my solution. If you're concerned that your shading is not up to par, okay? I had students ask if they could bring in highlighters, if they could bring in rulers. Yes and yes, okay? Whatever will help you do your best on the exam, Okay?
It's an exam and not a test.
It is a test. Exams are like, it's like the blanket term for quizzes and tests. Okay? All right, guys. Answer this last question. How do you know which side of each boundary line to shade? This is going to be the last part of the notes. Answer that question and then turn in your notes.